Thank you for the introduction. Today, I'm going to talk about Fujitsu Lustre contributions and its policy and roadmap. Ooh. Okay. So here is our outline with this talk. So first, current status of Fujitsu supercomputers development. First and current product development, and the next step towards exascale development also. So second is our main topics. So based on such kind of activities, Fujitsu decided the contribution policy and Lustre to the community. So here is a disclosure of the contribution policy and current contribution, next step. So finally, introduction of contribution feature, maybe infinite watch layer and directory portal, etc. So Fujitsu joined last year. Oh, it's all a year. So however, we don't have some presentation of how Fujitsu contributes to such a Lustre community. So this main part of this presentation is how Fujitsu contributes to the Lustre community. That's the main topics. So first topic, current status of Fujitsu supercomputer development. Here's Fujitsu supercomputer's history. Fujitsu has been developing a supercomputer since 1990s, so we have over 40 years. And also, Fujitsu has been developing a HPC file system. Before the K computers, we have been original file system for users. However, in the development of the K computer, there are requirements very huge, and so we changed our policy to Lustre-based file system. And maybe I have been talking so many about K computers file system FFS. So K computer is still top 500, and maybe a number 4 system in the world. And FFS on a K computer is the first 1 terabyte sustained idle performance file system in the world. That's it, noted. So we are now developing FFS for next post-FX10 system. Just maybe will be shipped in the next year. And the next target is an exascale system. So let's talk about some of the features. So maybe this describes somewhere in the roadmap. So Japanese researchers are gathering maybe 2010 and report on the exascale architecture roadmap in Japan. Here's based on a kind of post-K project in Japan. And here's maybe URL, so you can see the English version and Japanese version. But Japanese version is made of precise inside. Sorry. So in this roadmap, Japanese researchers define such kind of a condition. So maybe some construction. First is maybe 20 and 30 megawatt of electricity and 2,000 square meter space. That may be the currently K computer. Also maybe a storage and maybe conditional maybe a storage is total resolution will be 1 exabyte and bandwidth is 1 terabyte per second. This is based on calculated by the application need. So how Fujitsu development towards exascale. So Fujitsu will continue to develop Lustre-based FFS to realize the next generation exascale system. So this means need to continue to enhance Lustre vision. So, however, FFS already supports exabyte file system size. However, we have several issues to realize the real exascale file system. One of the issues is exascale design. For example, there are limited electric power and footprinting. This is including a computing system and storage system. So electric power is defined by about 20 and 30 megawatts. This includes a computing system. Also, footprint are limited. There building is already exists. So in that case, electric power for the storage system must be minimized because most of the power should be used for computing. It's a problem. Also, maybe this is an assumption. So in that case, the power consumption of the exabyte class storage system should be less than 1 megawatt. It is as an assumption. The minimum is very preferable. So what should be exascale file system design? As a K-computer file system design, how should we realize high speed and redundancy together? So in that case, how do we avoid I/O conflict between jobs? In that conditions, these are not realized in a single file system. So we have introduced an integrated layered file system. So how about exascale file system and storage design? Another trade-off target power, capacity, and footprint. And I calculated several options, but currently it's difficult to realize single exabyte and 10 terabyte per second file system in limit power consumption and footprint. Also, it's low cost. So we are now considering maybe a third storage layer for capacity is needed. So we are assuming such a 3-layer file system. And local file system for performance, second, a global file system for easy to use, and third one is an archive file system for capacity. This is my current options. So maybe here's the work of the PGB study after the insideHPC, and maybe some configuration is here. So local file system is maybe 10 petabyte per 10 terabyte per second. Also maybe a global file system is 100 petabyte plus, and also maybe an archive file system and HSM maybe 1 exabyte. Now here's the architecture. So maybe a raster-based file system in the center of the file system. Maybe for performance, maybe some application-specific file system are needed. Also maybe for capacity, maybe a HSM or other shared file system and a grid and cloud system will be considered. So let me talk about the issue for post-beta scale. This is also same as exascale file system storage design. So it needs some power-saving storage architecture for exabyte storage. Maybe I already talked about maybe 20 megawatt and 30 megawatt. This means total system power including a computing system. So some require total computer and storage power management needed. Also, second problem is Lustre is not ready for exabyte class size system. So it must be improved. I already talked. And some issues for realizing post-beta scale file system. This is how to realize application-specific high-speed file access to local file system. So it needs to investigate storage access pattern of target application. And second one is how to realize transparent file access among the 3 file systems. So maybe kind of maybe option is Lustre HSM or one option. Hot. So let's talk about the main issues. So we have decided Lustre contribution policy. And first one is Fujitsu will open its development plan and feedback its enhancement to Lustre community. I believe that LAD is the most suitable place to present and discuss, I think, really. So, secondly, Fujitsu basic contribution, opening a development plan and feedback its enhancement to Lustre community, no later than after a certain period when our product shipped. So here is maybe some scale. Maybe we open the developer plan and maybe some Lustre release. We are enhancement to Lustre and feedback. I think we will continue to this certain development plans. So let's talk about Fujitsu activities to Lustre community. We have done maybe step 1. Basic enhancement to core Lustre modules and with one cloud Intel. And step 2, I will present here. Here's the advanced function contribution by Fujitsu. So here's the contribution to basic enhancement, and with Intel, there are eight functionalities implemented, included. This is not a bug fix, are not included. And here's the contribution to advanced functions as in the next step. So Fujitsu is now being importing of enhancement into Lustre 2.x. And these, however, these features were implemented in Lustre 1.8 based FAS. So they have been used in our customers for customer include K computer. So we will start submitting patches for Lustre in 2015. For example, currently scheduled first one is InfiniBand multi-rail. Maybe we will start them January 2015. And second one is maybe automated epic recovery. And third one is direct quota detail around maybe started maybe 2015 April and second half of 15 such and so functions will be contributed. And here's the Fujitsu contribution roadmap. Here, so such a here. However, my execution may change by Fujitsu development and marketing strategy. I'm sorry. So let's talk about some brief overview of advanced function. First one is multiple InfiniBand interfaces, multi-rail. So this is only use multiple InfiniBand interface as a single Lustre NID, and improving data transferring bandwidth on a single Lustre node. Third one is improving redundancy against failures on IB. Later I will talk about detail later. 10 minutes. So second direct quota. This is also printed by letter. And third one is improving of single process IO performance. Maybe this problem is discussed in the morning session. And we improve single process IO performance. Our modification and some prototype achieve a 2 GB bandwidth twice as Lustre 2.5. Also, maybe we will provide the client QoS, also automated epic recovery. So let's talk about detail of the features. So current issues are InfiniBand multi-rail. For the client, MDS and OS cannot be used multiple InfiniBand interface. So in the case, maybe such kind of left figures. However, some failure occurs. These are almost maybe a failover occurs. That's also a problem. However, our approach is different. Add the InfiniBand multi-rail function into Lustre network driver. We call this O2 IB LND. So in that case, maybe all InfiniBand interface on the client can be used in a communicate with the server. And all IB connections are used by a round-robin order. So this is different in the current Lustre implementation. This is continued communication when a single point of InfiniBand failure occurs. So here's a figure of the left figure is like this, maybe 2 InfiniBand, client A and B, and MDS OS, such kind of thing. When a failure occurs, there are only switches maybe root is LND level. So client B and A and B and also maybe a server does not conscious such kind of failures. And here's a variations are multi-rail. So not only asymmetric connection, but also asymmetric connection for every node pair. So user can realize flexible configuration. So maybe only 2 and 2, and 2 and 1, and 3 and 2. This is not so suitable for workload sharing. Also maybe 4 and 2. This is configured by such kind of command. So how to use? I think it is also very easy. In that case, we are combining single NAD with multiple infinite interface. This is a client, maybe use a local IP address, maybe 10 and 11, and server side 11 and 13. And what our configuration maybe NID maybe 192.168.0.1 IP0. Or maybe something like maybe server side 0.0. So here's the configuration of the multiple conf. These are the options networks, auth IP0 and IP0. Oh, sorry, not IP2. This should be 1. Okay, sorry. Also, NID maybe IQ definition as such as field. LCTL minus such kind of field. And for client and server set. And it's also display material information also present. And here's the performance. Here's server Xeon E55 22.27 megahertz and bits using InfiniBand QDR FDR2. So result bandwidth also scaled by IBs. Here's a QDR case left side. It's also 1 HCA and around 3 GB per second. And maybe a 2 HCA, maybe a 5.2 to 5.7 GB per second. For FDR case, almost a single performance 6 GB per second. And maybe using a 2 HCA, it's around 11 GB per second. And here also maybe using NET self-test. For soup to single SS, here's a result. We use a performance over communication, so we use a RAM disk. And here's the result, maybe direct IO and 34 processes. Maybe a transfer size, maybe 1, 2, 4, 8 megabytes per second. However, maybe this is a QDR result. It's around maybe almost twice as 6 gigabytes per second around that. So let's talk about the direct quota. So what is direct quota? It is restricting number of I/O nodes and the number of blocks by individual directories. And all files and directory under the directory quota enable directory under the quota accounting. So this is also provided by 1.8 based APS, and Fujitsu is now implementing direct quota function into Lustre.x. So direct quota of the APS based on 1.8 has been used in production system for over than 2 years. So maybe we currently investigating how to implement, but it will be implemented on top of this quota framework. Maybe you can use along with this quota. And here's use case of direct quota. One is this is very useful for our customer. Use case one is for job directory. Quota can control file system usage for each job, not for ID user and groups. Second one, of course, you can share the directory. It's limited on the top of the directory. However, some only limitation is nested directory quota directory are not permitted because of the simplicity of implementation and performance. So how to use? Operations are same as the Lustre UID GID quota. So only quota check option only differs. So first, use set directory quota on the target directory. For example, LFS quota check -E and target directory. This counts on the number of IO node blocks of existing file under the quota directory. So second, set the limit IO nodes and blocks. This is the same as Lustre LFS set quota -D target directory, -B are the number of blocks, and -L are IO nodes and for mount point. This is of the deal. So how to enable limiting by directive order using LCTL command, conf param, and such like that, almost LCL set param, such kind of thing. And to check status is at LCTL get param command. So this is the last one, and here's improving single process performance. We are currently finished implemented on 1.8 base Lustre. And here's comparison between Lustre 2.6.0 and our result. And here's also Geon, same as machines, and we use QDR. And we will also use such kind of RAM disk. And we measure the IOR1 process. The right one is a result. It transfer size of 512K, 1 megabyte, 2 megabyte, and 4 megabyte. And maybe almost Lustre 2.6 and 0 and around maybe 1 gigabyte per second. However, FFS, prototype of FFS is around 2.2 or 550 kilobyte, and maybe also 2.9 gigabyte per second, 2 megabyte transfer size. So let me finish my presentation. So I talk about Fujitsu policy and roadmap. And Fujitsu will continue to improve Lustre for exascale system, and Fujitsu will open its development plan and feedback its enhancement to Lustre community. So I believe that RAD is the most suitable place to present and discuss. So several features will be scaled to be contributed. So infinite material, data quota, etc. So it's my finish of my presentation. Thank you for joining us.
I have a question about Infinity. I have a question about InfiniBand multi-rail feature. What is different about async channel bonding inside a FET, which exists natively in 1.5 of FET, as I remember? Or
is that difference?
Yes.
Current implementation and FET?
FET 1.5 have a feature named channel bounding. So it is able to merge several IB cards into one logical channel.
One particular channel? I don't know, maybe.
So in your case, you have merged two IB cards in single channel to the between nodes. So it should be same as channel bonding does.
I didn't understand your question, so please introduce it.
Okay.
Usually, maybe Lustre 1.x provides such kind of maybe TCP/IP socket is provides such kind of same functionality. So, but InfiniBand functionality are not supported. Is that not the question?
I think the question is that in OPED 1.5, there's new functionality to provide channel bonding. But I didn't know about that.
So maybe OFED level provided. Oh, that when is that function is supported?
Channel bounding provided from FET 1.5, as I remember correction. So it should exist 4 years ago. So in your case, you can just create bounding between two IB cards and assign IP addresses to this bounding interface and name this as to IB interface in Lustre. So in this case, you will have no changes in Lustre code, but you will able to use two channels in parallel. But in your case, as I see correctly, you have active passive. In your presentation, you have active passive switching in case of fail. It is correct?
Yes, we are considering including a fail.
But channel bounding will be provide access via two cards in parallel.
So maybe is that maybe our implementation may be related to Lustre. So in case of one Lustre function for each level, if maybe or if each level is the same as such kind of feature, just I think they are almost same. But I'm not sure about such a similar reliability functions also make sure such kind of for more 2 years. So we would like to such kind of test maybe of at level channel bonding. Is that the answer? Sorry, it's difficult here.
When these patches will be available? These changes, modifications which you showed us. So when they can be available for public? So is it possible to download them or?
Maybe we will start for this is a summit schedule. Maybe if you normally started with January 15th, maybe we'll be taking us. I'm not sure, but we need to discuss with maybe a gatekeeper or something like that. So we will discuss started maybe this is the schedule. So we start January, and I'm not sure how it takes to. So maybe I don't know. So maybe I believe something like 3 and 4 months later. I believe. Thank you.